Have you ever walked out the front door and wondered whether your dog or cat actually notices you're gone? Not whether they're bored, not whether they'll chew something, but whether they genuinely experience your absence in some meaningful way. It sounds like a simple question, but the science behind it is stranger and more layered than most people expect. Because what researchers have found isn't just that some animals miss their owners, it's that the bond itself, the one you built without really thinking about it, has left a measurable mark on their brain. So let's start with what most people assume. Most people assume that when a dog gets excited to see you come home, it's just because you're the person who holds the food bag. That the tail wagging is essentially a Pavlovian reflex. Stimulus, response, nothing deeper. And that cats just don't care either way. Both of those assumptions turn out to be wrong, not slightly wrong. Fundamentally wrong. In 1998, researchers József Topál, Adam Miklósi, and their colleagues in Hungary ran one of the most revealing experiments in animal behavior research. They took something called the strange situation test, a classic method originally designed to study how human infants attach to their caregivers, and they applied it to dogs. The test involves the owner being present, the owner leaving, and then the owner returning. Across 51 owner-dog pairs, what they found was that dogs behaved differently toward their owners than toward strangers in ways that directly mirrored how children respond to attachment figures. Not just more excitedly, differently. In a way that suggests the owner isn't just a food source, the owner is a social anchor. But if the owner is a social anchor, the next question is what happens when that anchor disappears. A follow-up study in 2013 by Lisa Horn, Ludwig Huber, and Friederike Range extended this further. When dogs were given a problem-solving task, their behavior changed depending on whether the owner was present. The owner functioned as what researchers called a secure base, the same term used in developmental psychology to describe how a toddler explores a room more confidently when a trusted caregiver is nearby. Not the same as a toddler, not running on identical wiring, but operating through a recognizably similar mechanism for recognizably similar reasons, which raises the obvious follow-up: does the length of the absence actually matter? In 2011, Therese Rehn and Rehn Keeling left 12 dogs alone at home for different durations, 30 minutes, 2 hours, and 4 hours, and measured what happened when owners returned. The dogs didn't dramatically fall apart while alone, but when the owner came back, dogs separated for 2 or 4 hours showed significantly more intense greeting behavior than dogs separated for just 30 minutes. More physical activity, more tail wagging, more attentive behavior, more sustained interaction. The duration of the absence had registered. It had mattered. And it came out in the reunion. Then, in 2015, Gregory Berns and his team at Emory University put dogs through awake fMRI brain scanning, which is exactly as impressive as it sounds because getting a dog to lie still in a brain scanner is genuinely an achievement and exposed them to a range of scents, themselves, a familiar human, an unfamiliar human, a familiar dog, an unfamiliar dog. The region they focused on was the caudate nucleus, which is associated with positive expectation and reward. The familiar human scent produced meaningful caudate activation. The owner wasn't in the room, just the scent, and the brain was already responding. And then in 2022, a research group led by Takafumi Kikusui published a finding in Current Biology that got attention for a specific reason. When dogs were reunited with their owners, their tear volume increased measurably. The same effect didn't appear when dogs reunited with a familiar person who wasn't their owner. Oxytocin, the hormone associated with social bonding, appeared to be involved. To be precise, this isn't dogs crying the way humans cry, but it's a measurable biological change the moment that specific person walks back in. Not any person, not a familiar face, that person. Now, what about cats? Cats are genuinely harder to study, partly because they're harder to convince to participate in studies. But in 2019, Kristen Vitale and her colleagues at Oregon State University ran the same type of secure base attachment test with cats that had been used with dogs and children. And what they found challenged the idea that cats are fundamentally indifferent. Many cats showed clear attachment behavior. They explored more confidently when the owner was present, They showed distress when the owner left and sought proximity when the owner returned. The behaviors were quieter than a dog's, but they were there. And then came a finding that made the cat case stranger than anyone expected. There's a 2017 study by Rehn Keeling and Rehn, the same Rehn who studied dogs, that found cats and their owners interacted more after longer separations than shorter ones. The cats weren't pacing. They weren't visibly distressed. But the duration of the absence had still registered, and it came out when the owner walked back in. Perhaps the sharpest cat finding, though, comes from a 2021 study by Saho Takagi and colleagues. They played cats the sound of their owner's voice coming from a speaker in an unexpected location, somewhere the owner couldn't plausibly be. The cats showed surprise. They oriented toward the unexpected source. What this suggests is that cats may maintain an internal map of where their owner is, even when the owner is out of sight, not following you, not waiting at the door, but quietly holding a map of where you are and noticing when that map stops making sense. What we can't do is get inside any of it. We can measure what the brain does, and we can classify the behavior, but we can't ask a dog what it felt like to wait for 4 hours. We can show that a cat tracked your voice location, but we don't know what that tracking means to the cat, whether there's something it's like to do it, or whether it's a process running quietly in the background with no experience attached. That question is genuinely open, and anyone who tells you it's settled is overstating what the science can currently reach. What the science can reach is this. The next time you walk out the front door, your dog's brain is already holding your scent, treating it as a signal that you exist and might return. Your cat may be quietly updating a map of the house that still has you in it somewhere. Neither of them is doing what you assumed they were doing. They're not reacting to food or noise or movement. They're waiting for you specifically, and their brain, it turns out, already knows the difference.